Unit 2, Learning Target Number 1. Write algebraic expressions to model real-world problems using variables to represent numbers. Writing expressions is basically translating words into numbers. So what we're going to do is look at each one of these problems and try to convert them or translate them into a numeric expression. We know that Nita had X number of fries, so we don't know how many, but we know she had some fries. She found 8 more fries in the bottom of the bag. We see the word more, and that indicates that something is increasing. And many times when it's increasing, that can be an indicator of addition. So Nita had X fries. She found 8 more in the bottom of the bag, so we're going to say X plus 8. And that is our expression. Notice, again, it's just variables and numbers and operators. Javier had 12 more action figures than Toby. So our keywords here, we've got 12 and we've got more action figures than Toby. So we use T as a variable for Toby, T plus 12, and that is the number of action figures Javier had as an expression. Elsa ran 3 times as many miles as Jack. We've got 3 here, and we've got the word times. We all know that times usually means multiplication. So, as an expression, this would be 3 times J, and J is the number of miles that Jack ran. So 3 times J. Then lastly, Will ate 7 less than 4 times the number of cookies Sienna ate. 7 less than 4 times the number of cookies Sienna ate. So we'll have a variable for the number of cookies that Sienna ate. We know that Will ate 7 less than 4 times that number. So we'll multiply that S by 4. 4 times the number of cookies Sienna ate, that's S. And Will ate 7 less than that. So our expression is 4S minus 7. Here are a few more expressions. Once again, when we're working with expressions, we're really looking for the different terms. And terms, remember, are just numbers and variables. And we're looking for the different operators. So we're looking for keywords to represent those things. So in number 1, we see the sum of 3 and the product of 2 and n. So the sum of 3 and the product of 2 and n. So we are going to start here. We know 3 is being added to the product of 2 and n. Well, product means multiplication. So the product of 2 and n would be 2n, 2 times n. The sum of 3 and the product of 2n would be 3 plus 2, because we have the sum of 3 and 2n. Let's look at number 2. The difference of 4 squared and the quotient of 2 and y. So we're looking for difference. And remember that difference means subtraction. The difference of 4 squared, and if I was to look at 4 squared, I know that 4 squared looks like this. 4 squared, 4 to the 2nd power. And the quotient of 2 and y. So the quotient of 2 and y, I know what that looks like. Quotient is division. So I've got the quotient of 2 and y. That's 2 divided by y. And the difference of 4 squared and this part right here. So 4 squared minus the quotient of 2 and y. So 4 squared minus 2 over y. Finally, the product of x and half of 5. So the product of x, that's my term, x. Product means, again, multiplication. Half means I'm going to be dividing something, right? Half of 5 would be 2.5, but we can also write it as 5 over 2. 5 over 2. So the product of x and 5 over 2, which can also be written as this, 5 over 2 times x. Let's take a look at our last 2 problems. These 2 are a little bit longer, but they're not really any more complicated. We just need to translate them. Eliza and 4 friends want to go to a movie. They won't know the cost of the tickets until they get to the theater, but the girls do want to spend $12 on popcorn. Let's write an algebraic expression for this situation. And remember, algebraic expression just means it has variables in it. So, Eliza and 4 friends want to go to a movie. How many people are going? 5, because it's Eliza and her 4 friends. They won't know the cost of the tickets until they get to the theater. So we know there'll be 5 friends times some amount for the ticket. Is that all they'll pay? No, because they want to spend $12 on popcorn. So 5x plus 12 is our expression for number 1. Number 2, Danny plans to buy a bag of candies for Halloween. She wants to divide the candy between her 4 friends. She wants to divide the candy between her 4 friends so that each person gets 7 pieces. Let's write an expression. We see divide and we know what that means. It means that we're going to be doing division somewhere. Whatever we divide, we don't know how many bags of candies she has, rather how many candies she has in a bag. So we'll put x right up here for the number of candies in the bag. We know she's going to divide it between 4 friends. And we know that each friend is going to get 7 pieces. So when she divides that bag of candy by 4, each friend should get 7 pieces. And that's our expression.